Right now, you're holding the future in your hands. That smartphone connecting you to the world contains 17 of the most critical elements on Earth, elements so vital that without them, our entire technological civilization would collapse overnight. Yet 90% of people have never heard of rare earth elements, despite using them every single day. These 17 chemical elements, the lanthanides plus scandium and yttrium, are the invisible backbone of everything we consider modern. Your phone's vibrant screen relies on europium and terbium for its colors. The powerful magnets in your earphones contain neodymium. Electric car batteries depend on lithium and cobalt. Wind turbines require dysprosium for their generators. Even the catalysts in your car's exhaust system use cerium and lanthanum. Despite their name, rare earth elements aren't actually rare in terms of abundance. Cerium is more common in Earth's crust than copper. The rare designation comes from their scattered distribution and the incredibly complex, expensive process required to extract and separate them from ore. This extraction process is so challenging that it has created one of the most dangerous geopolitical dependencies in modern history. A dependency that could determine which nations control the future of technology and green energy. Here's a shocking reality. China controls over 80% of global rare earth production, giving them unprecedented power over the world's technological future. This wasn't always the case. In the 1980s, the United States was the world's largest producer, mining these elements from California's Mountain Pass facility. However, environmental concerns and cheaper Chinese production gradually shifted the entire industry eastward. China's dominance stems from several factors. First, they possess significant rare earth deposits, particularly in Inner Mongolia's Bayan Obo mine, which contains the world's largest known reserves. Second, Chinese companies were willing to accept lower profit margins and environmental standards that Western competitors couldn't match. Third, Beijing recognized the strategic importance of these elements early and invested heavily in processing infrastructure. This concentration has created dangerous vulnerabilities. In 2010, China temporarily restricted rare earth exports to Japan during a territorial dispute, causing global prices to skyrocket and highlighting the risks of dependence on a single supplier. The incident served as a wake-up call for governments worldwide, but meaningful diversification has been slow. China's control extends beyond mining to processing and refining. Even rare earths mined elsewhere often get shipped to China for processing, as they've built the world's most advanced separation facilities. This vertical integration means that even if other countries increase mining, they still depend on Chinese expertise to transform raw ore into usable materials. What if I told you that the green technology meant to save our planet is built on one of the most environmentally destructive mining processes ever developed? Rare earth mining creates an environmental catastrophe that makes traditional mining look clean by comparison. The extraction process requires massive amounts of toxic chemicals and generates radioactive waste that can contaminate groundwater for generations. For every ton of rare earth elements produced, approximately 2,000 tons of toxic waste are created. The process begins with crushing ore containing rare earth minerals, which are typically mixed with radioactive elements like thorium and uranium. Miners then use powerful acids, including sulfuric and hydrochloric acid, to dissolve the desired elements from the rock. This creates enormous pools of acidic radioactive sludge that must be contained indefinitely. China's Bayan Obo region, the world's largest rare earth mining area, has become an environmental disaster zone. Toxic lakes stretch for miles, filled with black, radioactive waste. Local residents report increased cancer rates, birth defects, and respiratory problems. Farmland has become unusable, and water sources are contaminated. The irony is profound. The elements essential for solar panels, wind turbines, and electric vehicles, technologies designed to combat climate change, are extracted through processes that devastate local ecosystems. This environmental cost is largely hidden from consumers in developed nations who benefit from the finished products, creating a form of environmental colonialism where pollution is exported to poorer regions. Modern technology's reliance on rare earth elements runs deeper than most people realize. These elements possess unique magnetic, luminescent, and catalytic properties that make them irreplaceable in countless applications. Without them, the digital revolution simply couldn't have happened. Neodymium creates the strongest permanent magnets known to science, essential for computer hard drives, electric vehicle motors, and wind turbine generators. Europium produces the red phosphor in television screens and LED lights. Terbium enables the green phosphors in fluorescent bulbs and computer monitors. Dysprosium allows magnets to function at high temperatures, crucial for electric vehicle performance. The smartphone in your pocket contains approximately 16 different rare earth elements. The touchscreen uses indium tin oxide for conductivity. The speaker magnets contain neodymium. The camera lens uses lanthanum for optical clarity. The battery requires lithium and cobalt. Even the phone's ability to vibrate depends on rare earth magnets. Electric vehicles represent the fastest growing demand for these elements. A single Tesla Model S contains approximately 25 pounds of rare earth materials. As governments worldwide mandate transitions to electric transportation, demand is projected to increase by 400% over the next decade. The defense industry also depends heavily on rare earth elements. Precision-guided missiles, radar systems, and night vision equipment all require these materials. This creates national security implications when supply chains are concentrated in potentially hostile nations. Recognizing the dangers of Chinese dominance, countries worldwide are scrambling to develop alternative rare earth sources. The United States has reopened the Mountain Pass mine in California and is exploring deposits in Alaska, Wyoming, and Texas. Australia's Lynas Corporation operates the world's largest rare earth processing facility outside China. Canada is developing several promising projects, including the Strange Lake deposit in Quebec. However, developing new sources faces enormous challenges. Environmental regulations in Western countries make permitting extremely difficult and expensive. The Mountain Pass mine, for example, spent over $1 billion on environmental remediation before reopening. Processing facilities face even greater hurdles as communities resist hosting toxic waste storage. Japan has pioneered innovative approaches, including recycling rare earths from electronic waste and exploring deep-sea mining. Urban mining, extracting rare earths from discarded electronics, could potentially supply 20% of global demand. Japanese researchers have also discovered massive rare earth deposits on the Pacific Ocean floor, though extraction remains technically challenging. The European Union has designated rare earths as critical raw materials and is investing heavily in recycling technology and alternative supply chains. However, these efforts will take years to significantly impact global supply dynamics. Private companies are also innovating. Some are developing more efficient extraction methods using bacteria or specialized solvents. Others are working on substitute materials that could reduce rare earth dependency in specific applications. Rare earth elements have become weapons in modern economic warfare. China's ability to restrict exports gives them enormous leverage over countries dependent on these materials. During trade tensions with the United States, Chinese officials repeatedly threatened to cut rare earth exports, which would cripple American technology and defense industries. The economic implications are staggering. A complete Chinese embargo could shut down production of smartphones, electric vehicles, wind turbines, and military equipment worldwide. The 2010 export restrictions to Japan caused rare earth prices to increase by over 1,000% within months, demonstrating the market's vulnerability to supply disruptions. This dependency creates a paradox for Western nations pursuing green energy transitions. To reduce dependence on fossil fuels, they need massive quantities of rare earth elements for solar panels, wind turbines, and electric vehicle batteries. However, this increases their strategic dependence on China, potentially trading energy security for technological security. Military implications are equally concerning. Advanced weapon systems rely heavily on rare earth elements. The United States military consumes approximately 500 tons of rare earths annually for guidance systems, communications equipment, and radar technology. A supply cutoff could compromise national defense capabilities. Some analysts compare rare earth control to oil's geopolitical influence in the 20th century. Just as petroleum shaped international relations and conflicts, rare earth elements may determine 21st century power dynamics. Countries controlling these resources gain significant leverage over those dependent on advanced technology. The future of rare earth elements will determine whether humanity can successfully transition to sustainable technology while maintaining geopolitical stability. Several trends will shape this future, each carrying profound implications for global society. Demand will continue growing exponentially. Electric vehicle adoption alone could increase rare earth consumption by 300% by 2030. Renewable energy expansion will require massive quantities for wind turbines and solar panel components. The Internet of Things will multiply demand for electronic devices containing these elements. Recycling technology offers hope for reducing mining dependency. Advanced separation techniques could recover 90% of rare earths from electronic waste. Japan leads this field, with companies developing profitable urban mining operations. If scaled globally, recycling could supply 30% of demand by 2040. Substitution research is accelerating. Scientists are developing alternative materials for specific applications, though complete replacement remains unlikely. Quantum dots might replace some rare earth phosphors in displays. New magnet designs could reduce neodymium requirements. However, these alternatives often sacrifice performance or increase costs. Geopolitical diversification efforts will gradually reduce Chinese dominance, but this process will take decades. New mines and processing facilities require enormous capital investments and face environmental opposition. Meanwhile, China continues expanding its global influence through Belt and Road investments in rare earth projects worldwide. The ultimate challenge is balancing technological advancement, environmental protection, and geopolitical security in an interconnected world, increasingly dependent on these hidden elements. Thank you for joining us on this deep dive into the hidden world of rare earth elements, the invisible foundation of our technological civilization. These 17 elements may be unknown to most people, but they're shaping the future of everything, from smartphones to electric vehicles to renewable energy. Understanding this crisis is crucial as we navigate the challenges of the 21st century. The choices we make about rare earth mining, recycling, and geopolitical dependencies will determine whether we can build a sustainable, technologically advanced future without compromising environmental health or national security. If you found this exploration of rare earth elements as fascinating as we did, please consider subscribing to our channel for more in-depth documentaries about the hidden forces shaping our world. Your subscription helps us continue producing educational content that reveals the complex systems behind everyday technology. Don't forget to like this video if it changed your perspective on the devices you use every day, and share it with others who might be interested in learning about the invisible elements that power our modern world.